Hello and welcome to our discussion on crashing of a PERT network. Now, in the very first discussion on crashing, we saw that what are these additional details. This is normal cost, that this is the cost that will be paid for normal duration operations. Then if you try to crash these durations, if you try to speed these durations up, you can finish these tasks in these durations. 8 days, but it can be done in 5 days. 9 days, it can be done in 5 days. But whenever you try to crash an activity, whenever you try to crash an event, project, some additional expenses are incurred. For example, here a normal payment of 65 is needed. But if you try to finish it in 5 days, a payment of 200 has to be done. Now what is this? Mystery. When time is less, why payment is more? The idea is when time is less, you are running through using a private cab. So it costs you more. While in first case, you are running through public transportation, which is very cheap. So this is the idea that when you try to crash up an activity, the cost goes up. This was the cost slope that we calculated. We calculated for our convenience so that I can know that what is the cost for one day. Like in previous lecture, we saw that it is not necessary that I'll bring 8 down to 5. I might bring 8 down to 7. I might bring 8 down to 6. It is not at all necessary that you crash the activity completely. You can crash it in parts. I wish to save only one day. I'm ready to put in money to save it by one day. So, okay, I'll do it in 7 days. What is the cost for 7 days? Cost slope tells me that for one day I'll have to make an additional payment of 45. I'm already making a payment of 65. If I try to crash it by one day, I'll have to make an additional payment of 45. So it will cost me 110. 65 plus 45, that is 110 for 7 days. This we saw in previous lectures. Now today, when we meet, we'll talk about minimum duration methods. I'll put it over here. Minimum duration crashing. We are talking of minimum duration crashing. Last time we talked of minimum cost. And in terms of duration, it was optimum duration. Today we are talking of minimum duration. The idea of minimum duration is a little different from our previous case. Here the idea of minimum duration is that you have paths 1, 2, 5, 6. 1, 2, 5, 6. Then there is 1, 2, 4, 6. Then there is 1, 3, 4, 6. Then there is 1, 3, 7, 6. These are the paths. You find out their durations. Their durations are 8 and 7, 15 and 6, 21. 8 and 9, 17 and 7, 24. 6, 12, 19. 6, 10, 16. So right now the durations are 21, 24, 19, 16 when you are operating normally. Now, what this method for minimum duration crashing, this method suggests is that you find out what will be the critical during the, what will be the critical if you crash everything. What will be the critical if you crash all possible activities? That is the idea. Right now these are the durations. What will be the durations if everything is crashed? What will be the durations? 5, 5 and 4, 9, 9 and 4, 13. If everything is crashed, the durations will be 13. 5 and 5, 10 and 5, 15. 6 and 6, 12, 12 and 5, 17. 6 and 4, 10, 10 and 4, 14. So, right now who is critical? 24. But if you crash everything up, what will be critical? 17. This is the benchmark. What is the benchmark in minimum duration crashing? Critical path after all activities are crashed. That is the idea. That is the benchmark. Earlier, if you remember the previous question. Our benchmark used to be, if I'm at 24, my benchmark would be next critical, that is 21. Then if you remember, we had two 21s. Next one was 19. So I brought 21s down to 19. Then the next benchmark was 16. So I had to bring those 19s down to 16. Yes, I remember here by mistake I had put 18 instead of 16. So that should be counted as 16. So that will be 16. So this was the idea in previous, that you take your present critical and pull it down to next possible critical. But here what we'll do is, we have right now 24 as critical. We see what happens if I crash all the activities. If I crash all the activities, it comes down to 5 and 4, 9 and 4, 13 and so on. At that time critical will be 17. Right now the critical is 24, but in that scenario critical can be 17. These become my benchmarks. This 17 is my benchmark. I will bring all paths down to 17. This is the idea. Earlier what was the idea? Idea was bring 24 down to 21. Bring every critical down to next critical. 24 down to 21, 21 down to 19, 19 down to 16. That was earlier idea. Now the idea would be, first you ascertain what is your critical right now, 24. What can be your potential critical if you crash everything, 17. So bring everyone down to 17. Yes, what will be the sequence? The longest path goes first, then goes the second longest and so on. Whosoever is the longest at any point, that will be brought down to 17. That will be the idea. So how can I bring this 24 down to 17? Is it possible to bring this 24 down to 17? Where is this 24? 1, 2, 4, 6, 1, 2, 4, 6. Can I bring it down to 17? In order to bring this 24 down to 17, I need to save 7 days. 24, it is being done in 24. I wish to complete it in 17 days. So I need to crash it by 7 days. Can I crash this network by 7 days? I can save 3 days over here. I can save 4 days over here. 3 and 4, 7 already saved. I only need 7 days. 7 days can be saved. I can even save 2 further days over here. But I need only 7 days. I need to bring 24 down to 17. Now the next big question is, which 7 days? I have 4 days over here, 3 days over here, 2 days over here. What should be my combination? From where do I select my 7 days? I select my 7 days in such a way that they are the cheapest ones. Here I will be making a 45, I will be making a payment of 20, here I will be making a payment only of 60. So, this will be my first choice. How many days can I save? 9 to 5. 4 days are already saved. I need additional 3 days. From where do those 3 days come? This is my best choice. All 3 can come from here. So I am picking only these 2 activities. What will I write? I'll write crashing 2-4. First I am crashing 2-4. 2-4 by 4 days. At what rate? 20. Why are we writing this? So that the examiner knows how I reached from this network to next network, and so that I know what are the additional payments that I am making. Crashing 2-4 by 4 days. 2-4 by 4 days at rate of 20. 4 days done. I need 7 days. 24 should be brought down to 70. 3 days are coming from here. So what I'll write is crashing 1-2 by 3 days at what rate? 45. So 7 days done. Let us have a new network. One, 2, 3, 4, 5, 6 and 7. You have crashed this and this. So what will be my updates? My updates will be, this is now down to 5. Crash this by 3 days, this crash this by 4 days. So this is also down to 5. No updates needed, 6 and 6, and this is 4. Then here I have a 7-5 and possibility at rate of 60. Then here is a 7-4 at 40. Then there is a 6-4 at 20. Then there is a 6-4 at 30. So this was the original figure. This is my new network. These were the original durations. Now I have my updated durations because I have crashed everything. 8 is down to 5, 9 is down to 5. And next would be the durations. What are the durations? 1, 2, 5, 6, 1, 2, 4, 6, 1, 3, 4, 6 and 1, 3, 7, 6. Yes, one thing we missed over here. In each stage, we should have a network, we should have the critical and we should have total cost. What was the total cost over here? Total cost is this thing which was 625 plus indirect cost 50 rupees for 24 days. 50 rupees for 24 days. 50 for 24, that is 1200, that is 1825. To start with, my total cost was 1825. What about total cost now? Total cost 2 we can call it. This was total cost 1 because first stage. This is second stage. What will be the total cost? I start with 1825. Fine. I am making some additional payments. What are the additional payments? 4 into 20. 80 rupees additional payment. 3 multiplied by 45, that is 135 rupees of additional payment. These are the additional payments that I made. I made an additional payment to this team 2, 4. I made an additional payment to team 1, 2. These were the additional payments. These additional payments have been made. Now there should be some savings. What are those savings? How do we decide upon those savings? 1, 2, 5, 6 is 5 and 7, 7 and 5, 12, 12 and 6, 18. 5 and 5, 10, 10 and 7, 17. 6 and 6, 12 and 7, 17. 6 and 4, 10, 10 and 6, 16. So we see that this is 16 still. This 19 has come down to 17. The reason is that this was a common path. 1, 3, 4, 6. 6. We had a 6, 6, 12, 12 and 7. 6 and 6, 12, 12 and 7, 19. Sorry, this is 19, still 19. So we have a 6 and 4, 10 and 6, 16, 6 and 6, 12 and 7, 19. These two have come down. 21 has come down to 18 because I saved 3 days over here, which was common to both. So 21 comes down to 18. And in this case, 1, 2, 4, 6, I saved 3 over here and 4 days over here. So it is down to 17. So these are my new critical paths. What about savings? How do I decide upon savings? This was my earlier critical. My new critical is, now new critical is 19. My earlier critical was 24. After this step, my new critical is 19. So what is the saving? 24 has come down to 19. 5 days worth of saving. 5 days worth of saving means 50 multiplied by 5, that is 250. So my total cost 2 would be 135 and 80, making it 215. 215, net saving of 35. So this becomes 1790. Let us just check. 1825 plus 135 plus 80 is equal to this minus 250, making it 1790. So my new total cost is 1790. And if you remember, the idea is to bring everybody down to 17. Every critical path of the stage should be brought down to 17. Earlier critical was 24, it was brought down to 17. Now critical is 19, bring it down to 17. 1346, 1346. Who is critical right now? 1346. 1, 3, 4, 6. Bringing it down to 17. Benchmark is 17. I have decided in first step itself. This time benchmark gets decided in first stage itself. In previous question, when we were talking of minimum cost, not minimum duration, when we were talking of minimum cost, the benchmark was being revised. 21 came down to 19, 19 came down to 18. 24 came down to 21, 21 came down to 19. 19 was targeted for 16. So it changes. But this time, when we are talking of minimum duration, target point is fixed. Every critical needs to be brought down to 17. 24 was brought down to 17. Now this is the critical, bring it down to 17. Can we bring it down to 17? Do you see any kind of savings? No savings are possible. No days can be saved over here. No savings are possible. 19 being brought down to 17 means 2 days of saving. No saving, no saving. Yes, I can save 2 days over here. 2 days can be saved. So what do I write? I write crashing. What is this? 4/6. 4/6 by 2 days. At what rate? Payment would be made at 4/6 at 60 rupees. Why am I doing so? Because I need to bring the critical down to my target point, my benchmark that I've set. We have 1, 2, 3, 4, 5, 6 and 7. What are the durations? Only this will be updated. You have crashed 4/6 by 2 days. If you crash 7 by 2 days, it comes down to 5. So no further crashing is possible over here. These are already packed, 6, 6 and 4. These two are also packed, 5 and 5. This is 7, 4 with a cost of 40, 6, 4 with a cost slope of 20. All these paths are done. This is 6, 4 with a 30. Can I have my total cost and criticals? What about my criticals? 1, 2, 5, 6, 1, 2, 4, 6, 1, 3, 4, 6, 1, 3, 7, 6. 5 and 7, 12 and 6, 18. 5 and 5, 10, 10 and 5, 15. 6 and 6, 12 and 5, 17. 6 and 4, 10, 10 and 6, 16. My idea was to bring 19 down to 17. 19 is down to 17. But who is critical? In turn, my critical has again switched. From 1, 2, 4, 6, my critical came down to 1, 3, 4, 6. Now my critical has gone down to 1, 2, 5, 6. 1, 2, 5 and 6. This is now my new critical. Can I have my total cost? 3. Total cost 3. I started with 1790. I made some additional payments. What were those? 2 days 60 rupees, that is 120 rupees. I made an additional payment for 120 rupees. What were my savings? 19. Earlier critical 19, new critical 18. So there is a saving of 1 day. So there will be a saving of 1 day at 50. That is 50. My total cost has actually gone up by 70 rupees. 120 additional less 50. 70 gone up. So this becomes 1860. My total cost 3 is 1860. Now you can see over here 1825 came down to 1790. Now it has gone up to 1860, which is more than what I started with. But the good thing is that I started with a critical of 24. Now my critical is down to 18 only. That means I am saving 6 days. Now there are situations when you are ready to pay, but you want to crash the activities, when you want the job to be done as quickly as possible, irrespective of what it costs. So in this case, yes, it is costing me more, but I have saved 24 is down to 18. I have saved 6 days. In previous, if you remember, we stopped at 19. This time we have saved 1 further day, and we will still save further. Why? Because the idea is to bring critical down to 17. Who is critical? 1, 2, 5, 6. 1, 2, 5, 6. Can I bring it down to 17? Only 1 day is needed. You can save 3 days over here. You can save 2 days over here. Which one looks good? This looks good because it is the cheapest alternative. So what I'll do is, I'll make a new network. I'll write down what I'm crashing. What I'm crashing, I'll crash 5, 6 by 1 day. Crashing 5, 6 by 1 day at rate of 20 per day. the new network becomes one, two, we have a 3 over there, 4, 5, 6 and 7. You are changing this duration. 6 is being brought down to 5. So I'll write down this 5, 4, 6, 4 has become 5, 4 because instead of doing it in 6, I'm bringing it down to 5. And 20, 7, 4 at 40. We have a 5, 5, 6, 6, 4, 5, 6, 4, 30. Can we have our new critical durations? 1, 2, 5, 6, 1, 2, 4, 6, 1, 3, 4, 6, 1, 3, 7, 6. 1, 2, 5, 6, 7 and 5, 12, 12 and 5, 17. Which was the idea? Bring 18 down to 17. Everything has to be brought down to 17. Then the idea was 1, 2, 4, 6, 5 and 5, 10 and 5, 15. This has come down to 15, 6 and 6, 12 and 5, 17, 6 and 4, 10 and 6, 16. Now what is the critical this time? As a result of this crashing, this 18 has come down to 17. So I have two criticals in fact. 1, 2, 5, 6 is also critical. 1, 2, 5, 6. What is the critical path? You can check out in earlier lectures. 1, 3, 4, 6 is also critical. Critical is a path where you cannot afford to delay. Because if you delay anything on critical path, your project gets delayed. If you delay on this path, if this 6 takes 7, no harm. But if you delay on this path, this 17 will become 18. So my project ultimately gets delayed. So that is the idea. Now what about total cost? Total cost 1, total cost 2, total cost 3. This will be total cost 4. Now I'll be having total cost 4. Which started with 1860. Total cost 1, 2, 3. 3 was 1860. I started with 1860 plus I am making a payment of 20 into 1, that is 20 rupees. Then critical was 18, now it is down to 17. So 1 day saving. 1 day at rate of 50. Indirect is saved, direct is paid. This is what is paid and this is what is saved in each stage. 80, 135 were paid from here and this was saved because 24 came down to 19 at rate of 50. 5 days at 50. 120 was paid because of this. 50 was saved because 19 came down to 18. 1 day saved at this rate. Again 18 is down to 17, so 1 day saved at 50 rupees. The net effect would be a saving of 30 rupees. So it is 18, 30. We started with 1825. My cost is up by 5 rupees, but my project duration is down from 24 to 17 days. I have saved 7 days. Now if we compare it to minimum cost, or let us say this is minimum duration, if we compare it to optimum duration. This is minimum duration. In the previous question we did optimum duration. If we compare, this is optimum duration was 19 days. Well, this is 17 days. Minimum duration is 17 days, optimum duration was 19 days. Why was optimum duration 19 days? Because if I was trying to go further than 19 days, my cost was increasing. If I was trying to come from 19 to 18, my cost was increasing. That's why I stopped at 19. But this time cost is irrelevant. We are not talking of cost, we are talking of minimum duration, 17 days. So these were two broad categories, two broad methods of crashing. Two different methods of crashing, two different approaches to crashing. One approach was minimum duration, another was optimum duration. In optimum duration, cost is minimum. Fine. So these were our first two practice questions on crashing. In fact, introduction questions on crashing. Now we'll take a couple of practice questions on both methods. A couple of questions of minimum duration, a couple of questions on optimum duration, so that we are well versed. It is not that much complex method. Yes, you need to see when it comes down to parallel crashing. When we have two critical paths, we need to advance in parallel crashing. That is a time when we need to be careful, otherwise it is a very simple approach of crashing. So this was it for our third lecture on crashing. When we meet next time, we'll practice some more questions on both minimum cost and minimum duration. And until we meet next time, do take care. Thanks for watching. Bye-bye.